speaker 2 is better, doctor.
Yes. Speaker 2.
Speaker 2 is better.
Yep.
This one, yeah? This one is better. Hello? Is this better? Sorry.
Yes, doctor.
This is better. Okay, so the internal one is better.
Kalau jauh, this one better. Kalau jauh?
Okay, I'm going a little bit further from the speaker and I'm going to test the other speaker. Okay, we're still on speaker 2, but I'm going further away. Okay, speaker 2. All right, speaker 2. Now, speaker 1. Speaker 1. Hello.
Yes, doctor.
Which one better?
I think it's kind of on par with each other.
Okay. All right. So speaker makes no difference, but the camera is helpful, right?
Yeah.
Okay. All right. Thank you.
The camera is a bit convex, but it's kind of is okay.
Well, now I haven't changed the camera yet. Let me change to. Okay. Now this is internal camera. This is my laptop camera, so it's focused on my face.
Yeah, I think this one better, like a lot better.
Yeah, but this one is for me to write on the screen. I see what you mean. Yeah, it is a bit concave. Concave or convex? Concave lah. Okay, maybe we can adjust that better. 180. It's supposed to be a wide angle camera, but all right, we'll do some adjusting. This is just the first time. Okay, thank you for your feedback. We have a big audience here. Do you want to see them? No, wow. They don't want to show themselves. Okay. Okay, I hope all of you are here. How many of you are here today? I can see only 29 people. Well, I can't even see the 29 people, but it looks like there are 30 people in attendance. Let me see if I can get your, give me 1 minute while I get your attendance list organized. Okay, that's your attendance. See if you have problems with it. Okay, what am I going to do today? Now,
Doctor, how can I record my attendance?
I put the attendance list on the link to the attendance on the chat.
Oh, oh, thank you.
Okay, can you see what's on the screen? Class?
Yes, doctor, the examination.
Okay, now I want to go through this first because it's still fresh on my mind. And then after we're done with this, I will go to test two. Okay, now how many of you did not submit answers for this test? How many did not submit? Nobody's admitting?
Doctor, by submitting you means through Spectrum or like?
Spectrum. We are in test three. Test three, I only accepted Spectrum submission. Okay. How many did not submit or did not have enough time to submit? Test three, yeah?
Me,
Who you? Who's speaking?
Nabil.
Nabil.
Doctor, I messaged you at that time on the WhatsApp about my computer freezing.
Problem. Okay. You had your computer froze.
Yeah.
Okay, that one is okay. I think we sorted that out, didn't we?
Yes,
Who
doctor.
Yeah, who else did not submit? Because there were a few of you, when I was marking the script, there were a few of you who did not submit. Nobody wants to admit? Okay, I'm going to go back to Spectrum and see if I can open the Spectrum page. I don't suppose you can see my Spectrum, can you?
You can. I can.
You can. You can see my Spectrum page.
Yes, it's visible, Doctor.
Okay, good. It's okay. That's what I wanted in the first place. Test. No, this is not test 3. That's test 2. I'm just going to pull out a student name by in random, okay? Yusuf. Yusuf, are you online? Yusuf? Yusuf? Who's Yusuf Muhammad? Who is Yusuf Muhammad? Are you online, Yusuf?
Yes, yes, he is.
He is. Okay, Yusuf.
Wait, I
Okay, are you searching? Yes, Yusuf Muhammad. Yusuf Muhammad, supposedly online. Or maybe not online. No, he's not online. It's not online. Okay, never mind if it's not online. Let's go back to Rifa. Rifa? Rifa,
Yes,
are you
doctor.
online?
Yes, doctor.
Can I see you, Rifa? Can I just see your face?
Sure.
That's not your face. That's a still. Show me your live face.
Yes,
Ah,
doctor.
okay. All right. Rifa, you did not submit some questions, right?
Yes, doctor.
Why is that?
I couldn't finish.
You couldn't finish on time.
Yeah.
For test 3. Test 3 is just 3 questions.
Yes, doctor. I was like writing, but I couldn't finish.
Okay. All right. I understand. I'm just wondering whether what I wanted to check was whether you really could not submit or you forgot to submit,
Oh
because,
no. Not
okay,
me.
so you couldn't submit on time.
Yeah.
Okay, fine. Are there any of you, okay, thank you, Rifa. Are there any of you guys, are there anyone who forgot to submit? I'm talking about test 3. So everyone remembered to submit. Okay, there were some of you, especially for question 3. Okay, let's look at question 3. Question 3. Question 3. What were you supposed to do? Okay, use the method of undetermined coefficients to find the finite difference formula approximation to f prime x based on 3 equally spaced points, fx, fx minus h, fx minus 2h. So this one is like what I taught in class. Remember? Where you need to compare the left-hand side and the right-hand side and so on. And then you solve for A, B, C. Okay, because there are only 3 points, you need only 3 equations in order for you to solve for A, B, C. I should say 3/4 of you could do this. Okay, 3/4 of you could do this. But unfortunately, when it came to part B, okay, what is part B? This is part B. Can you see part B? Can you all see part B? Yes or no?
Yes, doctor.
Yes, doctor.
Okay. When it came to part B, now you are using the finite difference formula approximation to f prime x based on 3 equally spaced points, fx, fx plus h, fx plus 2h. What does this mean? What does this mean?
It means using part A to find the part B.
Exactly. You are using the same formula in A to solve part B. Now, some of you did not do that. You find f prime x. You were actually using, some of you were actually using the mid formula, the central difference formula, because you did f prime x plus h, f prime x plus 2h, and you add the two and you try to find f prime x. Now, why did you do that? You had already found the formula. You had already found the formula in part A. So why did you redo that part? How many of you did this? You redid your part B. Instead of using the formula in A, you calculated again. And of course, when you try and redo things, you make mistake. How many of you are guilty of that? You don't want to own up? Silent. You know, when you are silent, I cannot tell what you're thinking. It's bad enough that you are not in this class, but if you keep silent, I really don't know what's going on. Okay. If you're not talking, I'll just have to go on. No? Nobody wants to say anything? All right, we're still in test 3. Let's do part 1 first. Question 1, part 1. Use the Newton divided difference to find a fourth order polynomial that fits the following data. And then part 2, using your polynomial in 1, find P435. Okay, you actually need that question in part 2 for you to solve the question in part 1. Why is that? If you look at part 2, it says find P435, right? And where is 35? Going to the data, can you see what I'm pointing at? Class?
Yes, doctor.
Yes, doctor.
Okay, if you look at this data in the table, where is 35?
35 is somewhere between 35.
Somewhere
35
here,
is somewhere
isn't it?
between 30 and 40.
Between 30 and 40. Since it is somewhere between 30 and 40, what should you use? Newton forward difference or backwards difference?
Backwards.
Okay. Some, I should say 50% of you got this right. You use backward difference, but you don't tell me why. For you to get the full marks, when you use backward difference, you need to say why you're using backward difference. Even if you're using forward difference, you need to say why you're using forward difference. Okay? Now, how many of you did not use backward difference? Anyone guilty of that? Okay. All right. So you know who you are. Do you know why you need to use backward difference? I'm repeating myself, but do you know why you need to use backward difference?
I knew why, but I didn't mention why.
You knew why, but you didn't mention. You need to mention why. Okay? You probably will get the question correct, but you will not get the full. If it's if the question is allocated 10 marks, you will not get the full 10 marks. Okay? All right. Okay. So far, most people got this right. The question does not say how many decimal points you need to answer. So it's okay if you give in 3 decimal points or even in 2 decimal points. Okay. Are there any major problems associated with these two questions? It is not difficult, right? All you need to do is put the table up and then use backward difference, find B4, B3, B2, and B1. And then plug it into your polynomial, and then you solve for P4. Okay? Everyone all right?
Yes, doctor.
Okay, so can we move on? Not a difficult question, not a long question also. And from the marks allocated to it, you shouldn't use too much time on this question. Okay, next question. Determine if the coefficient matrix for the following. Let me just turn off my WhatsApp, okay? It's irritating me. Okay. Determine if the coefficient matrix for the following system of equation is strictly diagonally dominant. Okay, the question is talking about the coefficient matrix. How does the coefficient matrix look like? What is at the top row? What is at the top row of the coefficient matrix? Nobody knows?
The top line, 271.
271. Okay. So your matrix should be 271, 4, 1 minus 1, 1 minus 3, 12. Okay. So what is the answer to that question? Is the coefficient matrix strictly diagonally dominant?
No.
No.
Why not? Okay, I get like more than 90% answering me no. But you don't tell me, you did not tell me why. Why not? Okay, why not? Why isn't it strictly diagonally dominant?
Because in the first row, 2 is less than 7 plus 1.
It's less than 7 plus 1, yeah? Okay, what about second row?
That also the middle value is less than the first and third value sum.
As long as your diagonal values are the highest value for the row, then it is diagonally dominant. Okay? Right. So this matrix is not strictly diagonally dominant. So what do you need to do? That's the second part. What do you need to do?
We need to swap the first and the second equation.
Okay. You swap the first and the second row. Okay. And then part 3, we use Jacobi method. Now this one, most people get it right. Okay. Maybe some has colors mistakes and some give me answers in fractions. If you give me answers in fractions, how do I tell what is correct to 2 decimal point? Okay, so your answer, you can have fractions while you're working, but your answer for x1, x2, x3 should be in decimal form. Okay? Most people could do this. Now, the next one, find the exact solution of the system of equations. Some people give me this exact solution, or what they call exact solution, using Gauss-Seidel method. Can we do that?
Can. But I just wonder if, like, because what I did was I was kind of lazy, and since we have the estimation which is like 0.01 error, I just go and substitute it.
Now, I know some people did that. Yes, you were being lazy. If the question says find the exact solution, you find the exact solution. How do you know that your estimation is correct? How do you know that your approximation is correct? You could have made some mistakes. If the question says to find the exact solution, you find the exact solution. Okay, back to Gauss-Seidel. Can you use Gauss-Seidel to find the exact solution?
No.
Okay, earlier somebody said yes. Now we have someone saying no. What is it? Yes or no? Class.
No, because it's based on Gauss-Seidel is based on like guessing the initial values again. So it's not exact answer.
Okay. It is what we call a numerical method. Both Jacobi and Gauss-Seidel are numerical methods. If you want to find the exact solution, you cannot use Gauss-Seidel or Jacobi. You will need to use either Gaussian elimination or Gauss-Jordan. You can even use LU factorization. Okay, these three methods would give you the exact solution, but not Gauss-Seidel or Jacobi. All right, so when the question says find the exact solution of the system, you need to find the exact solution. Okay, and what about show the solution obtained from the Jacobi method converges? How do you answer that question?
I think you need to plot the graph.
Well, you can plot the graph. Yes, that could be one way.
I think if we do one more iteration in the Jacobi, we'll get the answer from the exam.
Well, actually, in the fifth iteration, you were already getting the answer.
I think the exact way to get to show that the Jacobi method converge is you need to find the exact solution. You need to find the exact root, and then in each iteration you find the error, the difference between the estimation.
That would be one way. Yes, you can find the error. Okay, that is why I asked you to find the exact solution in part 4. Okay, without finding the exact solution, you cannot show that your method is converging. So what you need to say is, with each subsequent iteration, as your number of iterations increases, okay, as the number of iteration increases, the value that you obtain from the Jacobi method is leading towards the exact solution. Okay, it is heading towards the exact solution. So, or you can say the limit, the difference in the limit is becoming 0. Okay, so That is how you show that the Jacobi method converges. Or you can look at the error, as some people said, the percentage error or the exact error. You don't even need to look at the percentage. You can just find the exact error. Okay, so that shows that for this particular question, the Jacobi method converges. All right, is that difficult?
Just wondering if like I sub the case root of the Jacobi into basically like I check if the estimation is right or wrong, and then I take that as a solution. Can I get any score?
You do get marks for it, but probably not the full marks allocated.
Oh,
okay.
thank you. Yeah,
As long as you're doing something which is logical, which makes sense, you will get marks, but maybe not the full marks. All right.
Okay.
Okay. All right. So far, so good. So far, so good. Yeah.
Yes.
Okay. Yes. Okay. Now part 3. We're back in part 3. Okay. I've discussed how to do this, right? Part A. Now part B, as we said earlier, we use the formula in part A to solve part B. So what do you need to do? That means when fx is 1, you need to plot it into the formula that you obtained in part A to find the derivative. Okay? All right? And you will see that even when you plot it into the formula for 1, 2, and 3, it will be the same as the exact solution. Do you all agree?
Yes.
Okay, that means your difference formula is true. Okay, because it says here comparing the results obtained using the exact solution, right? Okay. Determine for what value of H the difference formula holds. So for part 1, part 2, and part 3, for what values of H?
I found 1 and -1 for H. I'm not sure if it's right.
1 and -1, no. For part 1, part 2, and part 3. It is for all values of H, right? No matter what H is, part 1, part 2, and part 3 will give you the same solution when you use the difference formula and the exact solution. Do you all agree? For all values of H. Now, a lot of people did not answer this question. Okay, so for part 1, part 2, part 3, it is for all values of H. Okay, what about part 4? In part 4, using the finance formula, you will get something like
3x something plus 2h something.
something, yes. Where is it? You get 3x squared minus 2h squared. All right? You get 2x squared minus 3x squared minus 2h squared. Okay? Now, but you know that the exact solution is only 3x squared. So for what values of h is this true? Okay, I'm going to this whiteboard now. Using exact solution. Fx equals 3x squared. 3, is it 3x squared? Is x cubed. X cubed, isn't it? X cubed. Let me check. Yes, x cubed. All right, fx equals x cubed. So if exact solution will give you f prime x is 3x squared. Can you see me? Can you see the whiteboard? Can you see the whiteboard? Yes? Nobody answering?
Yes, we can, doctor.
Okay, all right. Okay, so that is the exact solution. But using the formula, what do you get?
Using the formula, we get like 3x squared plus minus 2h squared.
3x squared. Using the formula, you get 3x squared minus 2h squared. Okay, when will this in the box be equal to the red box?
I think it's supposed to work if h equals 0.
Yes, it will be only when h equals 0. Okay, now a lot of people did not answer this part. Why is it?
Because like I was in the hurry and then I didn't quite understand the
What
question at that
required?
time, so I don't want to risk my time.
Okay, okay, fair enough. Okay, so that is test 3. Only 3 questions. It wasn't a difficult test, but quite a handful got A's. I think about 20 people got A. I'll put up their results later after class, okay? I've just finished marking just before I went to the hospital this morning.
Doctor, I actually have a question.
Mm.
So for the direct differentiation, when we do it, we do like from x cube we have 3x 2 plus, oh no, sorry, I got my answer, sorry. Okay, I got my answer, sorry, doctor.
Your answer, okay. All right. About 20 of you got A. But at the same time, I have 2 people getting Fs and a handful getting Ds. So if we can have more than 10 people getting A's, it's not a difficult test. So what went wrong? Look at it again and see where you went wrong, where you think you could have gone wrong. All right? Any questions?
This is like 10%, right?
This is 10%, yes.
Can I ask about the test 4, the upcoming test 4?
Well, test 4 is after Raya, isn't it?
Yeah, but I just want to know, like, will it include the part, the chapter 2 to 6, like again?
It will be everything.
Okay.
Everything that you have studied up till that point. Okay. Now, how many of you did not submit your assignment? Assignment was also 10%. In fact, I sent messages for you people who did not submit. How many people are here today? 41. Okay, there are 7 people missing. You know who you are. If I call out your name, you will make a big fuss. But 2 of you did not submit your assignment. Okay? And you did not even bother to answer my messages. All right, so if you have a good excuse, you can send me a message and I will see if I will accept your excuse. But otherwise, then you get 0. Those of you who did not submit assignment. Test 1 was objective, so that was out of the way. Now test 2. Do you all want to go on or you want a break?
Break.
You want a break? Break for 15 minutes or 10 minutes.
Just want to know what after we talk about test 2, what do we have?
After we talk about test 2, I want you to do the review paper. I put up a lot of review paper. I hope you have done them. But the review paper that I put up recently, I want you to do that in class.
Okay.
So that if you have any questions, you can ask.
I think we might want to just go through the test 2, and then after that we have a break, and then we go back to the revision.
All right, we go to test 2 then. Okay, no problem. Let's look at test 2. If I can find test 2. Okay, can you see? Can you see test 2 on the screen, class?
Yes, doctor.
Okay, first question, find the root of fx equals to x cubed minus 20, correct to 3 decimal places using the secant method for 3 iterations and the initial value of x naught. Oh, before I forget, back to test 3, the Jacobi method. The Jacobi method, you were supposed to do 5 iterations. No, 5 iterations. Does it include 0, 0, 0? I repeat, when you are counting your number of iterations, does it include the initial values given as 0, 0, 0?
I am not sure, but I included.
Okay. Now, the initial value is what was given to you. You did not calculate that. Okay? You did not calculate the initial value of 0, 0, 0. But what you do need is you need that initial value to find your first iteration. So the first iteration would be the value that you get for x1, x2, and x3 after you plug in your initial value. That is your first iteration. Okay, let me see if I can find the table. Okay, if you look at this, can you see my table?
Yes, doctor.
Wrong table, sorry. Where is my table? Where's my table? Can you see my table now? No?
Yes, doctor.
You can see the table.
Yes, doctor.
Okay. If you look at the table, we've got x1, x2, x3, 0, 0, 0. I put 0 there. Can you see that?
Yes.
Okay. So 0, 0, 0 is not counted as the number of iteration. After you plug in your 0, 0, 0, then it's your first iteration and subsequently. So if you had counted 0, 0, 0 as your first iteration, you will need to go to 6, n equals to 6. If you want to count 0, 0, 0 as your first iteration. There were one or two of you who made that, who did that. Okay? All right? So please bear that in mind. Can you tell the difference, class?
Yes. Yes, doctor.
Okay? Now, remember, your initial values should not be counted as your iteration. You use your initial value to find the first iteration. It is after you have used your initial value, only you start counting your number of iterations. But if you do want to count your 0, 0 as an iteration or your initial value, then you will have to go one step higher than what is required. Okay, you understand what I'm saying?
Yes.
Okay, good. All right, back to test 2. Okay, now I don't know why some of you got secant method and Newton-Raphson method mixed up. It's an open book test. Your notes are in front of you. How did you get them mixed up? Would you like to tell me how you got them mixed up in an open test? Class? Do you want to tell me how you got everything mixed up? No? Okay. So how do we do this? Secant method, what is the formula? Again, it's an open book test. No reason for you not to know the formula. And you are supposed to do only for 3 iterations. Class, what is the formula? You mean up till today you don't know what the formula is? Daniel, you said maybe because of late compilation. What is the problem with late compilation? What does it cause? Late compilation makes you forget the formula. Oh, the answers are jumbled up. Okay, okay. Okay, don't wait until the end to submit your answers. Submit your answers for every question. You finish one question, you submit. You finish the next question, you submit. Don't wait until your time is almost up and then you can't submit anything. If you submit one question at a time, then at least if you don't have enough time, you will only miss submitting one question. But if you wait until everything is over before you submit, there is the danger that you don't submit a single question. And you don't get things jumbled up if you submit a question at a time. Okay, class? All right? Yes, no? Okay. All right, so what is the formula for secant method? Okay, what is the formula for Newton-Raphson method? Okay, I allow you to look at your notes. Go and look at your notes.
For Newton-Raphson, it's xn plus 1 is equal to xn minus f xn upon f dash xn.
Say again.
Xn plus 1 equals to xn minus fxn upon f dash xn.
Okay, right. What you need is the value of the function at the present point minus the ratio between that value and its derivative. Okay? That will lead you to the next value of the function. That's Newton-Raphson. Okay, what about the secant method? Remember, the secant method uses 2 points. The secant method uses 2 points. So what is it? FC. You can use FC. You can use fx plus 2. You can use fx plus fn plus 2. What is the formula? Okay, look at your notes and tell me what the formula is. Okay, we've got it here. Xn plus 1 is xn minus xn minus 1 over yn minus yn minus 1 multiplied with yn. Now, what is y? Y will be the value of the function at xn, right? You can use y, you can use fxn. Makes no difference. Okay, so for the secant method, as I said, you need 2 points. So in order for you to find that derivative, the next iterations, what do you need to do? Can you see the table? Can you see the table? Is this secant? Yep. Okay, that is your formula. Do you all agree?
Yes, doctor.
Okay. Now the question says 3 decimal point. So at each step, you put your values in 3 decimal point. Then your value at the final value will be nearer to what is required by the question. Okay? Because the question wants answers in 3 decimal points. Okay, so it should be at every point you convert your answer to 3 decimal points. And then the second part is to find the difference, the percentage difference. Okay, so the percentage difference the definition is provided. All you need to do is just plug in your answer. Now, again, we have people using the initial value as part of the iteration, which is not correct. So these are all just simple mistakes that you all make. All right. Question one, not difficult. Do you all agree? Is question one difficult? Silence. No. Okay, question two would be the Newton excuse me. Question two will be the Newton-Raphson method, which is even simpler. Okay, let's see now. Newton-Raphson. This is secant. Where is Newton-Raphson? Okay, this is Newton-Raphson. All right, but the initial value this time is 3. Okay, most people got this correct actually. You've got your results, right? Test 2. Anyone disappointed in the results for test 2? Are you all okay with the results for test 2? Okay, if you're silent means you're okay. You don't say anything means you're okay. Yes. Are you about to say something? Okay, so Newton-Raphson is fine. Now next will be write a pseudocode. Now you've already done this actually. You've already written the pseudocode. Now all you need to do is just produce it here. Okay, write an algorithm or pseudocode for the bisection method for finding the solution of polynomial within an interval a, b, accurate to within a specified error. So all you need to do is just produce the pseudocode that you've written earlier. And I'm not even going to test whether your pseudocodes work or not, because they're not complete programs, okay? As long as you have the basic things in order, you should be able to get the marks for it. Okay, second part, using the algorithm written or otherwise, find the solution of fx equals to x squared minus 2. Now someone gave me x squared minus 2 is square root of 2, which is 1.414, without using any algorithm or without using the bisection method. How did you get that square root of 2 is 1.414? I know what you did was you used your calculator or you use your computer to give me a square root of 2. But the question says to use the bisection method. Okay, so you should use the bisection method. Either you use the bisection method manually or you use your algorithm written. But because you have not tested your algorithm, it would be wiser for you to actually do it manually. Okay, for this question, I would advise for you to do it manually. Okay, now this question, yeah.
Doctor, so if someone used the algorithm in part 2, will it be okay?
If you use the algorithm, that means you actually tested your algorithm on the computer and you pass the codes, you pass the value,
Yes.
and you print screen your results.
So
That is what I would, if you are using your algorithm, then what I would expect is put it your whatever codes you're using, R, Python, or even Octave, and then you pass whatever values, whatever the function is, and you come up with with an output, and you print screen your output and your codes, and you provide it in the solution. Yeah, then that's okay.
So does it mean that if, let's say, I want to develop the because I know that my handwriting is quite slow, so it is possible to, if I would just code it beforehand and then like code it in the manner that it shows step by step, and then I capture the screen and then pass it as an answer.
Yes, you can do
Okay.
that.
Oh my God. Okay.
You can do that. Because this question is actually quite open, part 3. Normally, in a test or in an exam, we don't expect you to write computer codes, but we just want algorithms or pseudocode. But if you want to use your algorithm to find the solution, then you've got no choice. You've got to do the proper coding. Okay.
Let's say if in test 4 I knew, let's say I code everything, all the method already. Can I just run the code and then submit the output?
Yes. Run the
Oh
code,
my God.
submit the output, and submit the codes as well.
I could have known it earlier. It's kind of
Okay.
easier for me to code than to write by hand.
All right. Okay. So that question is not fair, not really that difficult lah. Okay, number 4, using Newton's divided difference. Okay, so what do we do here? Newton's divided difference. Find the missing value of y. Find the missing. So first you have to find P3. First you have to find P3. Okay, but you were informed that the coefficient of x3 is 1. Find the missing value y. Is it difficult? No answer. Is it difficult? How do you find y? Okay, after you find P3x, okay, using this table you can find P3x, right? But y will when you are finding the difference, it will be a little bit messy, because you don't know the exact value. What you will need to do is y minus 26 over whatever. And then as you go up higher, you will still work with y. But then once you plug it into P3, you can find y because you know that the coefficient of x3 is 1. How do we do this? Okay, let me see. Most of you could do this. Is this what you get? Is this what you do it? Okay, y minus 26, 4 minus 3 is 1. And then for the second divided difference, is this it? But you still have values of, this should be y, not p. Okay, this should be y. All right. And then you plug it into your P3. Your P3 is this. This is your P3. And you're told that the coefficient of x cubed is 1, meaning that this fraction that you have here is 1. Solving it, you get y equals 64. How many of you did not get that correct? How many of you did not get that correct? How many could not solve for y? All of you could solve for y? Okay, very good. If you could all solve for y, very good. Okay, so again, not a difficult question. Agreed? Do you all agree that it's not a difficult question? In fact, test 2, most of the questions are easy. Okay, the next question, determine if, now, this question is related to the next one. Sometimes you might get this first, sometimes you get the matrix first. If you get the system of equation first, okay, what I would suggest, class, when you have questions, just look through your questions before you answer them fully, because it may be worth the effort for you to see if there are any questions which are related. Do you know why? Do you know why? Those two questions, the one on solving the equation and the one on the LU factorization, they were related. But because you did not look through the questions to see if there are any related questions, some of you actually redid your LU factorization. You had already found your LU factorization, but when you come to solving the system of equation, you did it again without realizing that you are solving something you have done before. Or maybe you do your system of equation first. Okay, if you do your system of equation first, it's okay. It's fine. the thing is, some of you did your system of equation first, you use LU factorization, and then when you come to the question on LU factorization, you did not realize that it is the same matrix that we were working with, and you did it again. Do you understand what I'm saying? So actually, if you look at test 2 properly, the question on determine if the following matrices have LU decomposition, and if yes, find the LU decomposition, and the question on solve the following system of equations, they are actually very much related. And if you had done this question, the LU factorization, you can easily solve the system of equations, or even if you had done the system of equation first using LU factorization, you would be able to find the LU factorization for A and B easily. But because you did not check for questions which are related, you did not see the relationship. Okay? How many of you did not realize that the questions were related? Did you redo? Did you redo? Those who did not realize the two questions were related, did you redo? Yes. Okay, so my advice in future, check if your questions are related. And do you know why I don't inform you that the questions are related? Until I saw the resulting upon. Yeah, okay. You mean you did not realize when you were working with the matrix, you didn't realize that the coefficient matrix were the same? Okay, do you know why I don't inform you that the questions were related? Can you think of any reason why I did not inform you that the questions were related? Nobody wants to try? Think, or make a wild guess. Why do you think I did not inform you that the questions were related? Is your own loss, right, for not realizing that the questions were related? Because you were doing something which you have already done. In fact, some of you redid and then got it wrong the second time around, although you got it right the first time. You can't tell why I did not inform you? Okay, one is because this is an open book test. Everything is provided for you. So I want to see whether you are observant enough to realize when questions are related. Everything is given, your notes, you can look at your notes, you can do whatever you want. Okay, you can use software to solve. Yeah. Okay, so I wanted to see whether you are observant enough to realize when I give you bonuses. This is like a bonus question. So When I give you bonus, you did not even realize it's your own loss. Just take 1 or 2 minutes to look through the questions and see if questions are related. Otherwise, you will not enjoy the benefits given to you. Okay, class? Hello? Am I talking to the wall? Okay. Hello? Okay. All right. Next question. Still in test 2. Is that the end? That is the end, isn't it? Yep, that's it. Not a very difficult test, and yet some of you did not do as well as expected. Okay, let me see. Test 2. This is test 2. This is test 3. Where are the results? Test 2 results. Well, wait. I won't show the results. You all should know your results by now. I'm just going to look at the graph. Let's look at the graph. Where is my graph? Ah, that's the graph. Can you see the graph?
Yes, doctor.
Okay. Yep. Okay. Can you see that there are about 20 people who got A and less than 5 people got A minus? So it's heavy to the A side. Okay. It is very much heavy to the A side, which is expected actually because it's an open test. You got all your resources to work with. But at the same time, I still have this. Why do I still have C minus, D plus, D and F? People in this category, what is the problem? People in that category, what is the problem? What is the problem? Are you in class today? People who got C, C minus, D plus, D and F. Are you in class?
I think I'm gonna talk as a person who got a D. I think I haven't practiced enough, so like I think there might be an error in my writing. I'll take it as a head up. So yeah.
Who's that talking? Who's that
Tarin.
talking? Tarin. Okay.
Yeah. I think it's okay. To be honest, I'm kind of ashamed of my result, but I feel like I haven't practiced enough. I will take this as a heads up, and I will try to do better.
Okay. Use this opportunity to improve. Okay.
Yes.
Good. All right. Any more? Any more in that category? No more. No more who are present today in this class. Right? Okay, overall, are you all satisfied with the test? Like I said, I will put up results of test 3 as soon as possible. Okay, you've got one more test and then it's your final. But we've got 2 more topics. We've got, what have we got? We've got integration, numerical integration, and we have boundary value problem and initial value problem, IVP and BVP, which is related to partial differentiation. Okay? Partial differentiation. Okay, 2 more topics, 1 more test. You think you could do enough?
I will try my best, doctor.
Okay, those of you in the A category, please don't get overconfident, yeah? I think you are the same people, right? Okay, any questions? Any questions? Okay, if there are no questions, please do revision 3. Is it revision 3 or revision 4?
Question 4.
Revision 4. Okay, please do revision 4. If you have not done revision 3, do revision 3 as well. I will be online and you can ask me question. But we will use this session as a tutorial session, and we can use it for your own benefit. All right? Like I said, I will be online and you can ask question. Do revision 3, revision, even if you haven't done revision 2, do revision 2. So you've got 4 revision papers. I'm sure revision paper 4 you have not done, so at least do revision 4. All right? I'm going to give you a break now. I will come back in about 15 minutes or so. Class? And I expect to see, okay, I expect to see you all in class doing your revision paper. I might ask you to show me what you've done. Okay, I will pick some students and ask me to show what you've done for revision 4. All right? Okay, I'll see you back in a few minutes' time. Okay, I'm back. All right, let's look at what you need to do, yeah? Okay. First question, can you all see the screen?
Yes, doctor.
Okay. All right, can you all get started on those questions if you haven't? Question 1 and question 2 are the same. Okay, where is question 1 and question 2? Question 1 and question 2 is the same. Okay, glad to see that you notice. Has anyone finished question 1? Has anyone finished question 1? Mirzad? Mirzad, are you here? Are you in the class?
Yes, doctor.
Have you finished question 1?
I'm trying to.
Trying to. Would you like to show how much you've done? Mirzad, you want to show us what you've done so far? Silence? Or he's disappeared? Does anyone want to show what you've done so far for question 1? We're still on question 1. Who would like to show? Mirzad does not want to show us. Anyone else wants to show? Said Martin, are you in class?
Yes, Dr. I'm in class.
Okay, would you like to show what you've done for question 1?
Yes, I'm almost finished with it. I
Almost
just need to
finished,
take
okay.
a screenshot.
All right, you finish it then.
I'll finish in like 3-4 minutes. Is it okay if I just take a picture with my phone?
Yeah, sure. You can send it in the chat. Okay, let's see now. Can you all see what Syed has posted? So we've got upper triangular matrix and lower triangular matrix. Do you all agree?
So I'm using Gaussian elimination. So at first I get
You?
upper matrix. So it only took 3 steps, right? So I made basically the lower triangle R0, and then the L is basically the operations we took to get the upper triangle. So, but minus that. So like if on the first step I did R2 minus 3 R1, it would be, it was negative 3, right? So on the lower triangle I would put positive 3. Same for the other 2 steps. Sorry, my handwriting is very bad. And then so that's basically what we get for the lower triangle. And then on the lower triangle, the diagonal would be all ones using this approach.
Okay, and your row 2. Okay, but it would be a good idea if you could show step by step how you got your L. Okay, from the operations to the E matrices to the L. All right?
So I would have to show like R1 times R2 times R3.
Yeah, that's right. Okay, step by step.
Sure.
Because normally when we are giving marks, we look at step by step. All right?
So that would like, if we don't show it, it's like basically losing some marks, right?
Well, if your final answer is correct, then you won't lose much. But if your final answer is incorrect, then there's substantial marks lost.
I see.
Okay.
Thank you.
All right. Anyone else want to show what they've got? Maybe for question 1, part 2? Question 1, part 2. Anyone wants to show? Anyone wants to try? Oh, by the way, you are supposed to test first. Always test first whether the matrix can be reduced to LU. Okay, you've not shown that. Okay, but in future, bear in mind that you should show whether it's possible to get, because the question did say where possible. All right. So you have to show if it is possible and why is it possible. Okay, who is showing me this? Okay, we've got no name, so I don't know who's posted this.
This is mine, doctor.
Okay, all right, okay, I can see, yeah. Okay, Maral, okay, good. Okay, let's see. You want to explain it, Maral?
Yes, doctor. So it's there. I got the upper triangle matrix with only 2 operations because we already had 1 0 in the first column in the 3rd row. So, and then while getting the row operations, I was getting the inverse elementary matrix as well along with it. And then L is the production of E1 inverse and E2 inverse.
All right. Everyone agrees? No sound means you all agree? Silence, total silence. Okay, let's just do question 2. Anyone wants to show? Have you done? Okay, get started with question 2 if you haven't. 10 minutes and I'll ask you, I will pick one of you up to show your answer. Okay, question 2. Okay, anyone ready? Question 2, part 1. Use LU decomposition to solve the following system of equation. Anyone wants to show us? Would anyone like to show? No? Okay, then I will call out a name. Volunteers first. Any volunteers? No volunteers, then I will call someone up. Yo Chun Yung. Yo Chun Yung. Are you in class? Yo Chun Yung, are you in class? No? Chun Yung, are you in class?
Yes, doctor. Can you hear me?
Yeah, now I can hear you. All right, would you like to share your work?
No.
Why not? Why not? Never mind. If there's a mistake, you learn from your mistake.
Because I'm now using phone to on the lecture.
Oh, you're on the phone. Okay. Why are you not using a laptop or a PC? Okay, in that case, on the phone it might be a bit difficult to show. Who would like to try? Who would like to show? Okay, Melissa. Melissa.
Okay, let me take a screenshot.
Okay. Right. Let's see now. Okay, you've got your LU decomposition, and then you solve for Y, and subsequently solving for X. Everyone agrees? Everyone agrees? Silence. Do you all agree, class? The rest of you, do you agree with Are you doing it the same
Yes,
way?
doctor.
Okay, good. Okay, can we have another one? Who would like to volunteer? Come, don't make me call your name out. Just volunteer. If you've done, just volunteer. We are still doing a question 2, still on solving the equations. Okay, that's the equation that we have. Question 2. Who's showing question 2? Part 2?
Doctor, I sent out for 2 parts. Question
Okay,
2
all right.
part 2 and question 2 part 3.
All right. Okay. Good. Anyone has any questions? Any questions? Okay. Let's go back to question 3. Question 3 is on Jacobi. Anyone wants to try? Part 1 is easy. It's just 2 variable. Part 2. Would anyone like to try part 2? Anyone wants to try part 2? Volunteer, please. Question 3, part 2. Okay, do we need to make the diagonal entry positive? Why do you want to make the diagonal entry positive? Who's asking this? Shanwei, why do you want to make the diagonal entry positive? You need to make it diagonally dominant, yes, but you don't need to make it positive. Okay? All right, for both Gauss Seidel and Jacobi, it is best to work with diagonally dominant matrices, because otherwise the values that you find may not converge to the exact solution. Okay, so yes, in answer to your question, in fact, the question asks you to make it diagonally dominant. Okay, let's see what Pang has put. It is not diagonally dominant. Your screen, your picture is blur, so I can't read what you've written. Okay, it's not diagonally dominant. I suppose you giving the reasons there. And in order to make it diagonally dominant, what do you need to do? You need to exchange the second and the third row. Do you all agree that in order to make it diagonally dominant, you exchange the second and the third row? Yes. Do you all agree, the rest of you?
Yes.
Okay. All right. Once you made it dominant, how would you use, is the question on Jacobi or Gauss-Seidel? Is it Jacobi? Okay. Jacobi, 5 iterations. Would anyone like to do? Would anyone like to do? Okay, I'm waiting for a volunteer for the Jacobi question. Okay, you has got some answers here. Let me see if I can increase. Okay, his handwriting is really small. First, initial value is 0, 0, 0. Are you working with the same number that we put up earlier? 4 minus 1, 1. Which question are you working on, Shiyu? Okay, okay, it's this one. All right. Okay, fine. Okay, do you all agree? In the first place, is that diagonally dominant? Okay, let me just read what you all said. Yes, okay. Okay, so do you all agree with what he has done then? Okay, and any problems with the answers obtained? Any problems with the answers obtained? Okay, looks like there are no problems. Do you want to go on? One last question. We'll do one last question and then we'll stop. Okay. Right. Let's look at Gauss-Seidel for a change. Let's do number 6. Gauss-Seidel method. 5 iteration. Initial value 0, 0, 0. Okay. Get started. Question 6. Question 6. Any volunteers? Question 6. No volunteers for question 6? Good. Okay, diagonally dominant matrix. Everyone agrees that's diagonally dominant? Okay, and we are using Gauss-Seidel, aren't we? We are using Gauss-Seidel, so is that correct? What is the difference between Jacobi and Gauss-Seidel? Can you all tell me?
Jacobi is like you do the entire iteration and then you sub with the result. But for Gauss-Seidel, once you get like if you do an x, you use the x into the sub iteration.
Okay, right. With the Jacobi method, you have to complete the iteration before you use new values. But with Gauss Seidel, the minute you get new values, you just use it, right? In the next, although it's just part of an iteration. Okay, it does not matter. Okay, so let's go back to what, can't remember his name. Who did it? Who was it? Wong Wei. Okay, let's look at what he's done. Now, the font is really small. I'm trying to see 3 plus x2 plus x3 over 4. Okay, the first value is correct. Now, with the second value, you need to substitute the new value. Okay. All right, 9 plus 2 into 0.75 minus 0 over 6. Agreed? Everyone agrees? And then with x3, you got new values for x1 and x2, 0.75. Okay, that's it then. Okay, and you do the same with the second iteration and the third iteration. Okay? All right, class? Okay, any questions? Any questions?
No, doctor.
Okay, if there are no questions, we will stop here. All right? And I will see you after the break, right? Next week is break, a Hari Raya break, and your mid-semester break. And then we'll come back in the, what week is this? Is this the 10th week?
Yes.
Okay, so we'll come back 12th week, right? In week 12. Okay, I'll see you then. All right, enjoy your break. And for those of you celebrating, Selamat Hari Raya or Eid Mubarak. And for those not celebrating, enjoy your holidays. Please don't go anywhere. Stay at home. Everyone stay at home, okay? Okay? All right, bye then.
Thank you, Doctor.